All right, everybody, let's get to it. So prime factorization. Um, so we've kind of already done this in the last video. To do it, I'm going to do a factor tree. What's something that divides into 28? Well, 4 does 7 times. 7 is a prime number because nothing divides into it except 1 in itself. 4 is not. 2 divides in twice, but 2 is prime. And now every branch on my tree has a piece of fruit, the circle at the end. So it's going to be 2 times 2 times 7, or you could say 2 squared times 7. That happens. All right. So that's, kind of what's going on there. Let's see. Yeah, they just did 2 times 2 times 7. Okay, cool. All right, let's do one more. So 60, let's see, that's 6 and 10, neither of which is prime, but 6 is 2 and 3, they're both prime. 10 is 5 and 2, they're both prime. So every branch has a piece of fruit on the end. We've got a couple of 2's, a 3, and a 5, or 2 squared times 3 times 5. And again, this is the way that Alex is going to do it, at least at this point. All right, now we're going to take it up to the next level. So find the greatest common factor of 26 and 48. So in other words, what's the biggest number that divides into both of them? So here's the strategy for doing it. I mean, you might be able to do it in your head, but all right, 26 is divisible by 2 because it's even, and it goes in 13 times, and that's also prime. Okay, so 26 is 2 times 13. Then we can say, all right, let's break 48 down. 48 is 4 times 12. 4 is 2 times 2. 12 is 4 times 3. 4 is 2 times 2. So 48 is equal to 2 to the 4th times 13. Or, well, no, times 3. Looking at the wrong one. So there's 1, 2, 3, 4 2's. That's why we got a 4 right here. Or you could write them all out. Okay. And that would be fine too. Okay. So, so the greatest common factor of these two numbers is going to be found by doing this. I say, all right. I just take what they have in common. Okay. Because again, it has to be a factor that works for both of them or is common to both of them. Well, they both have a 2. You know what? Here, let me just keep that circled. Whatever. They both have a 2. What else do they both have in common? Well, nothing. If there was one more 2 up here, I could say, yeah, okay, let's slap another 2 in there, but that's not the case. They don't both have a 13. They both don't have a 3, so 2 it is. So 2 is the biggest number that divides into both of these. And there will be plenty of math problems throughout your journey of algebra and stuff where you use this idea of GCF. So the sooner you get good at it, the easier life is going to be. Let's do one more. Okay, 15 is 3 and 5, both prime. 32 is 4 and 8. 4 is a couple of 2's, and 8 is 3 2's. Okay, so what do they have in common for prime factors? Nothing. So when that's the case, the only thing that divides into both is 1. So yeah, so if the GCF is 1, that means you've got nothing here and here that's common. Okay, that's cool. Let me try something with just a little more zip to it. Okay. How about we go to, let's make up, let's do Let's do 60. Sorry, it's a little hard to read. 60, and we'll say 48. Okay, like we've already seen, 60 is 6 times 10. 6 is 2 times 3. 10 is 2 times 5. Okay, and then 48 is 4 times 12. 4 is 2 times 2. 12 is 4 times 3. And 4, again, is 2 times 2. So we'd say, what do they have in common? Well, they both have a 2. Hallelujah. They both have a 3. And they both have another 2. And then that's it. So the greatest common factor, the biggest thing that divides into 60 and 48 is 12. That's how we do it.